Hello everyone. Today we will see some practice questions from the chapter solution, and this is part 1. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slides and we will going to study or see some practice questions from question number 1st to question number 10th. Let's start with the question number 1st. A 1 molar solution of sodium chloride has a density of 1.21 gram per milliliter. The molarity of the solution is. We have to find out the molarity. Options are 4.15 molar, 1.143 molar, 2.95 molar, or 3.15 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option is B. So the molar mass of NaCl, let's suppose it is M2, is given by 58.5 gram. And we can calculate the molarity of the solution by the relationship we know between the molarity and the molality or density, which is given by molality multiplied by density upon 1 plus molality into the molar mass divided by 1000. On putting the given values in the question, in this equation, we have molarity is equal to 1.143 molar. Hence, option B will be the correct answer. Okay, let's move to the question number 2. The density in gram per milliliter of a 3.6 molar sulfuric acid solution having 29% H2SO4 by mass will be. Molar mass of H2SO4 is given as 98 gram per mole. Options are 1.64, 1.88, 1.22, or 1.45. So you have 10 seconds to solve the question. After that, we will see the answer. Okay, so the correct answer will be option C. So molarity is given by 10 into density into percent by weight of solute divided by molecular weight of the solute. So density equals to, on putting all the values and interchanging the terms, we have density equals to 3.6 into 98 upon 10 into 29. And it is coming out as 1.216 gram per milliliter. And it is approximately equal to the value given in option C, that is 1.22 gram per milliliter. Hence, option C is the correct answer. Let's move to next question, question number 3rd. The molarity of a solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. So we have given the volumes and the molarities of two solution, and basically same solution but having different molarities and volume, and they have been mixing, and we have to find the final molarity of final solution mixture, right? So options are 1 mole, 1 molar, 1.75 molar, 0.975 molar, 0.875 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is option D. So we use this equation here that M1V1 plus M2V2 equals to MV. And M1 and M2 are the molarities of two solutions, and V1 and V2 are their volumes. And MV is the final molarity and final volume of the final solution after mixing of two solutions. So, which is total, moles MV. So, we can find out the molarity, which is this plus this upon V. So, M1 V1 plus M2 V2 upon V will be total volume, right? So, V1 plus V2. And on putting the values given in the question, molarity is 0.5 into 750 first solution volume plus 2 molarity and 250 volume of second solution divided by V1 plus V2, and 750 plus 250, that is 1000. And so molarity is coming out as, on solving this equation, 0.875 molar. And this is the same value given in the option D. So option D is the correct answer. Okay. Let's see the next question, which is question number 4. 10 milliliter of 2 molar NaOH solution is added to 200 milliliter of 0.5 molar of NaOH solution. What is the final concentration? Same thing is happening here. Two solutions are mixing together having different molarities and different volumes. So we have to find out what is the final concentration of the solution. Options are 0.57 molar, 5.7 molar, 11.4 molar, 1.14 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option is A option, that is 0.57 molar. Let's see how. So final concentration we calculate in the same manner as we did in the previous question. So final concentration M is equals to M1 V1 plus M2 V2 divided by V1 plus V2, where M1 and M2 are the molarities of two solutions, and V1 and V2 are the volumes of two solutions which are mixing together. So on putting the values given in the question, 10 into 2 plus 200 into 0.5 upon the sum of volume, that is 200 plus 10. And on solving this fraction, we have value of final concentration as 0.57 molar. And hence option A will be the correct answer. Okay, so let's move to question number 5. The density of a solution prepared by dissolving 120 gram of urea, which has molar mass of 60 unit. So dissolving 120 gram of urea in 1000 gram of water is, the density is 1.15 gram per milliliter. We have to find out the molarity of the solution. So density is given, gram of weight of urea is given, weight of water is given, and we have to find out the molarity, right? So options are 0.5 molar, 1.78 molar, 1.02 molar, 2.05 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D, which is 2.05 molar. Let's see how we will solve this question. So the total mass of the solution, which is forming by mixing urea and water, is 1000 gram of water plus 120 gram of urea. So it will be 1120 gram of solution. And density of solution is given as 1.15 gram per milliliter. And we can find out the volume of the solution using the density formula, that is density is mass upon volume, so volume will be mass upon density. We just interchange the terms, and on putting the values of mass and density, we have 1120 gram divided by 1.15 gram per milliliter, and on solving this fraction, we have the volume of solution in liters as 0.974 liter. So the moles of solute will be given mass upon molar mass, and given mass of urea is 120. Molar mass of the urea is 60. So moles of solute, that is urea, moles is coming out as 2. And now we can find out the molarity of the solution, that is moles of solute. So moles of solute we have calculated as 2, and divide by volume of solution in liter, which we have calculated already, which is 0.974. And on solving this fraction, we have molarity is equal to 2.05 mole per liter. Hence, option D is the correct answer. Okay, let's move to next question. Question number 6. The density of 3 molar solution of sodium chloride is 1.252 gram per milliliter. So we have given a density for the sodium chloride solution, which is 1.252 gram per milliliter, and the molarity of the solution is 3 molar. The molality of the solution will be, so we have to find out the molality of the solution. Here, there's a difference. Molarity is given and molality we have to find out. So molar mass for the sodium chloride is given as 58.5 gram per mole, which we have to use in the solution. And the options are 2.6 molar, 2.18 molar, 2.79 molar, or 3 molar. So small m is for molality. And you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So we have given 3 molar solution. That means 3 moles of solute NaCl are present in 1000 liter of solution, right? As the density is given in milliliter. So we can say that the 3 moles of solute are present in 1000 liter of solution. So mass of solution we can calculate, find out by the formula of density, that is volume into density. Density is mass upon volume, so mass will be volume into density. And mass of solution we will calculate by multiplying the volume of solution, which is 1000, multiplied by the density, which is 1.252 as given in the question. And it is coming out as 1252 gram. And mass of solute is equal to number of moles multiplied by the molar mass of the NaCl. So the molar mass, number of moles is 3, and molar mass of NaCl is 58.5 gram. So the multiplication is coming out as 175.5 gram. And mass of solvent is equal to the mass of solution minus the mass of solute, which is 1252 minus 175.5 gram. It is coming out as 1.076 in kgs. So molality is given by moles of solute divided by mass of solvent in kg, right? So it will be moles of solute is 3 upon mass of solvent is 1.076 in kg we have calculated. So the molarity is coming out as 2.79 molar, right? Okay. So the next question is question number 7. A 5.2 mole aqueous solution of methyl alcohol is supplied. What is the mole fraction of methyl alcohol in the solution? So we have given the mole of aqueous solution of methyl alcohol, and we have to find out the mole fraction of methyl alcohol present in the solution. Options are 0.1 molar, 0.19 molar, 0.086 molar, 0.050 molar. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer will be option C. Molality is given by moles of solute upon mass of solvent in kg. So moles of solute is 5.2, right? And solute is CH3OH, that is methyl alcohol. So 5.2 mole for CH3OH, and mass of solvent in kg is 1 kg, and or 1000 gram H2O, right? So the moles of the methyl alcohol or methanol is 5.2. So moles of H2O will be given mass upon molar mass. So 1000 gram upon 18 the molar mass, which is coming out as 55.56, right? And we can add the moles of both solute and solvent for getting the moles of total moles of solution, and it is 60.76 mole. So now we can find out the mole fraction of CH3OH, which is the number of moles of the solute or the CH3OH divided by the total moles of the solution. So 5.2 divided by 60.76 total moles. And on solving this fraction, we have mole fraction of methanol is 0.086. So our C option is the correct option, right? Okay, let's move to the question number 8. 25 ml of a solution of barium hydroxide on titration with 0.1 molar solution of hydrochloric acid gave a titer value of 35 ml. The molarity of barium hydroxide solution was. So we have given a solution of barium hydroxide of volume 25 ml, and it is on titration with 0.1 mole solution of hydrochloric acid. Give the titer value as 35 ml. So we have to find out the molarity of barium hydroxide solution. And options are 0.07 molar, 0.14 molar, 0.28 molar, or 0.35 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So let the molarity of the barium hydroxide solution is M1, and let the molarity of hydrochloric acid is M2. So M1V1 equals to M2V2, we know, and we can apply it as we know that it is the titration volume, or which is coming out as 35 ml, right? So the M1V1 will be equal to M2V2. So M1 into V1, which is 25 ml, equal to M2, which is 0.1 into V2, which is coming out as 35. So the 25 ml of barium hydroxide uses 35 ml of hydrochloric acid. So there the mass, or M into V molarity into volume, should be same. Number of moles should be same. So the M1, if we calculate from this equation, it is coming out as 3.5 divided by 25. And on solving this fraction, we have M1 equals to 0.14 molar. So the molarity of barium hydroxide solution is 0.14 molar. So B is the correct option. Okay, let's move to question number 9. At 100 degrees Celsius, benzene and toluene have a vapor pressure of 1375 torr and 558 torr respectively. Assuming these two form an ideal binary solution, then calculate the mole fraction of benzene in vapor phase at 1 atmosphere and 100 degrees Celsius. So we have to calculate the mole fraction of benzene. Given is the vapor pressure of benzene, vapor pressure of toluene, and we have to assume that they form an ideal binary solution. So options are 0.247, 0.753, 0.447, or 0.553. So you have 10 seconds to solve this question. After that, we will see the answer. So the correct answer is option C. And let x1 is the mole fraction of benzene, and 1 minus x1 will be the mole fraction of toluene. And we know that 1 atmosphere equals to 760 torr. So applying Raoult's law, we have total pressure equals to the mole fraction of solute into vapor pressure of solute plus 1 minus mole fraction of solute into vapor pressure of solvent. On putting the values given in the question in this equation, we have mole fraction of our benzene is equals to 0.247 torr. So mole fraction of benzene in vapor phase at 1 atmosphere will be uh, the mole fraction equal to the multiple of mole fraction in vapor pressure divided by total vapor pressure. So it will be 0.247 into 1375 divided by 760. Okay, and it is coming out as 0.447. Hence, option C is the correct answer. Okay, let's move to question number 10th. An aqueous solution of 2% weight by weight non-volatile solute exerts a pressure of 1.004 bar. At the boiling point of solvent, what is the molecular mass of solute? You have to find out the molecular mass of solute. Options are 0.3655, 36.55, 41.37 or 40.16. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is C option. So we have given the vapor pressure as 1.013 bar and which is equals to 1 atmosphere at boiling point. And weight of solvent is 100 minus 2, which is 98 gram. Because if we, assume that 100 gram and the aqueous solution of 2% non-volatile solute is existing. So 100 minus 2 will be the weight of solvent, which is 98 gram. So according to Raoult's law, we can say that P0 minus P1 upon P0, that is relative lowering of vapor pressure, equals to the weight of solute upon molar mass of solute into molar mass of solvent upon weight of solvent. So fraction of the moles, right? So it is coming out as 1.013 minus 1.004 upon 1.013, and it is equals to 2 into 18 upon m of solute into 98. And from here, the molar mass of solute is calculated as 41.37 gram per mole, right? Here in the first line, we have taken 1 atmosphere in bar, nothing else, okay? Because in the question, we have given the pressure in bar, okay? So this is the solution, and hence the correct answer is C option. Okay, thank you.